respected chairman, members of the audience, welcome. Thanks for joining us. It's a pleasure to be speaking with you here today. My name is Pratik Agarwal, and I'm here representing Thermo Solar System. So a little bit about myself before we delve into the topic. I'm a chemical engineer, and after doing my bachelor's in chemical engineering, I worked for about a year as a process design engineer. Went to the US to pursue my master's, and for about 10 years, worked there in myriad of different technologies, trying to commercialize new technology in pharmaceuticals, hyperscale data centers, and if you will believe it, even in finance, field not known for new technology. But about 2 years back, I came back with the singular objective of promoting environmentally conscious and ecologically friendly technologies in the Indian subcontinent. Of course, this is a great time with all the revolution that is happening on the economic side in the country. I think this is a time when we really need to focus on the ecological technologies, because if we don't do it now, I think the time when we can do it will be past, and everything will get much more expensive, much more difficult to adopt. With that introduction, I'll dive into the topic that we are supposed to discuss today. Conversation, we are going to structure it in a simpler three-part presentation. The first part is going to be a brief introduction about renewable energy, how it is evolving, what is the role of smart grids, the microgrids, and digitization in its evolution. Second, we'll briefly touch upon the path to net zero and how the role of solar energy specifically is going to be a big lever, but how we also need to innovate in how we are utilizing that lever to really achieve the path to net zero. And third, finally, I will present an evolving opportunity where we can use non-PV solar solutions to further our goal of net zero and promoting the clean and green energy in the new environment of transition to the renewables. So talking briefly about what exactly is a smart grid. I think Mr. Chandrasekhar gave a brief intro about it. But if you think about smart grids, it's a very simply put, it's a grid that allows for two-way flow of electricity. It's a grid that incorporates digital technologies, which allows for advanced determination of potential causes. And it's a grid that allows for responding to potential flaws and potential upcoming crises ahead of the time. Of course, you need to build in the necessary sensor framework. You need to adapt the entire grid in a way that it works in conventional metrics, but in a way that fits the new age paradigm. Within the smart grids, there is a new term that we talk about, the microgrids. Now, what is a microgrid? Simply put, microgrid is when you adapt an electrical circuit out of the main grid and create an island-like structure that allows for utilization at the source of generation. Now, this is a critical parameter for adapting solar or adapting renewable energy in a way at scale without overloading the grid and without succumbing to the weaknesses that comes with the peak loads and non-peak hours when the renewable energy flows onto the central grids. Digitization is obviously the lever that allows us to make this happen. Talking about path to net zero, as mentioned by, as released in a study by the International Energy Association, the global renewable generation capacity must triple by 2030 if the world as a whole is to achieve its goal of net zero by 2050. Now, of course, India is not targeting 2050 as its net zero goal, and for very understandable reasons. We were late to the party. We have less to contribute to the climate crisis that has happened in our times. But at the same time, while we are conscious of contributing positively and mitigating that climate crisis, we do not want to leave behind our people for the sake of moving from cheap conventional energy to expensive renewable energy. At least that was the case a few years back. Now with that being said, the biggest lever that we have all gotten behind is the solar PV to meet our renewable energy targets. I think in a presentation yesterday, someone mentioned this, that of about 200 gigawatt capacity of renewable capacity that has been added to the grid in India, more than 100, and I think the figure was 120, but don't quote me on it, but 120 gigawatts came from solar PV. Now this makes sense. It's the easiest scalable solution for generating renewable energy, adding it to the grid, and when doing at scale, it's easier to make the changes to the grid to allow for that solar PV energy to be transmitted as opposed to any other singular solution. So it makes sense that the industry, the government, and the world as a whole has put their weight behind solar PV. But you know where solar PV doesn't really do the best job is in our industry where thermal energy needs to be generated. If you're aware, in our industry, most of the processes, most of the processes require high heat temperature to transition chemicals or materials from one form to another, or to dry material. So I think instead of solar PV, a solution where we are using solar thermal energy is a much better suited one. It allows you to bypass the drop in efficiency at two steps. First, when you convert the solar into electricity, and then when you transition electricity through the grid, and third, when you utilize that electricity in your thermal conduits. So solar thermal is a solution I think we also need to discover in a big way and really go deeper into and promote its adaptation if we are really to achieve that last mile goal of achieving net zero. Now, when we talk about solar thermal, there's a specific opportunity within solar thermal that I would like to speak with you today. And that is using solar thermal energy in our wastewater treatment plants, where we can use solar energy for cost-efficient and environmentally responsible disposal of sludge. Now, I'm sure most of the audience has a question, what is sludge? Well, to put it simply, it's a solid byproduct that is generated out of our wastewater treatment plants. Wastewater treatment plants are basically can be grouped into two buckets. The treatment plants that treat our sewage, so we call them STPs or sewage treatment plants. And the second is effluent treatment, which is generated out of our cities, out of our industry, which is effluent treatment plant. Both of these plants, the water treatment plants, when they recycle water, they filter it, they treat it, and then they route it back to the consumption, either within the city or the industry. However, as an unavoidable byproduct of this process is when you filter something, you have a filtrate, but then you have what got filtered out. And this filtered out material is what we call sludge. If you look at the image, you see at the bottom right, that image, that's what sludge looks like. It's not a pretty material to handle, but it is a big problem for our country as a whole. Why do you ask? Couple of reasons. When sludge is generated, it is not generated in small quantities. A wastewater treatment plant, or the total wastewater treatment plants in the city of Delhi, I don't know the exact numbers, but I'm very comfortable in claiming that they generate in excess of 100 tons per day of sludge. That's per day. If you take that in a year, that's 36,500 tons. You know how much space that takes? We did a calculation that if just the city of Surat, which generates about twice the amount of sludge that I just mentioned for Delhi, if we were to dispose that in a landfill, which is what we do today, the amount of land it will require is the entire volume of the Narendra Modi Cricket Stadium in Ahmedabad, which boasts about greater than what, 100,000 people sitting in one go? Now, if that is the amount of sludge being generated in one city, just the community sewage disposal, how many Narendra Modi cricket stadiums do we need if we take into account all the cities, all the industry, and then we take into the account the fact that the growth of our economy is rapidly expanding, the systems are getting in place better and better, this sludge increases in an exponential fashion. So, in fact, and there are a couple of other problems that the sludge creates, other than the intensive land use. You know, if we talk about our urban land usage, one of the biggest problems that we discussed in urban planning is urban land usage. In urban settings, we create a landfill, dump the sludge, city, in 2 years, the landfill gets filled out, the city expands, we have to set up a new landfill, and we have to excavate the existing landfill because you can't build new properties on a landfill for many of the purposes in the urban usage. Second is, you know, the sludge, when it is filtered out, it's not just solid. If you actually do a chemical analysis, you will find more than 80 to 90% of the weight of the sludge is water. That's it. This water, as of today, is kept in the sludge and disposed of. So when you do this, I'm sure as you can let your imaginations run wild, once you dispose it in the landfill, the water starts percolating, goes into our soil, goes into the underwater ground resources, something that are already in short supply these days, and pollutes what remains of a very critical resource as it is. Thirdly, this sludge is not cheap to transport either. So as it is, when the generation sites transport the sludge from, you know, the wastewater treatment plant all the way to the dumping site, that's thousands of rupees transporting just 1 ton of sludge. So there are a lot of problems that sludge creates, including the cost to land, to the exchequer, as well as to the environment. So the solution, how do we solve this problem? The solution to this problem is drying the sludge before we dispose it off. Now, you ask, well, drying is easy. We dry a lot of stuff. Why don't we dry the sludge already? Well, as an industry, for most things that we don't do, the answer is money. Drying the sludge costs a lot because you have to supply conventional energy, either in form of coal, or in form of steam, or in form of electricity. Because you require high heat to dry the sludge, the amount of cost you incur is more than 5 rupees per kg of sludge. So instead of drying, they just ship it because shipping it costs 3,000 rupees on an average. Obviously, I'm talking about the India averages. So as of today, no one is drying it because of the cost. Now, second question comes that, okay, if the sludge cannot be dried based on conventional methods, is there any other solution that is there, either to prevent the ecological risk or prevent the cost that is incurred? So yeah, for specific harmful sludge, including chemicals, so for example, when you get sludge out of ETPs, out of the industry, that often contains chemicals. So government has mandated that chemical sludge cannot be disposed of in general landfills. So they have created TSDF sites in which industry needs to dispose of that sludge. Now yes, that does prevent some ecological risk, but still not a permanent solution. So the real solution is to dry this sludge, but to dry this in a cost-effective way. That's wherein comes the concept of solar sludge drying. As I said, one of the biggest cost factors in drying sludge is the conventional energy that we need to supply to it. So a way to bypass that is to adopt this technology which utilizes solar energy, specifically the infrared radiation radiation of the solar energy to heat up the sludge and dry it in an automatic fashion. I'm sure we have all heard about the term solar greenhouse. So that is the principle that this technology employs. Now, what is a greenhouse effect? Greenhouse, so solar energy comes in form of electromagnetic radiation, and it comes in many waveforms. One of the waveforms is utilized for creating electricity, utilizing solar PV. But then there's the other radiation band, which is called the infrared radiation, which we are not utilizing in solar PV based electricity generation. Solar greenhouse traps the electromagnetic, the infrared radiation, the short wave radiation, into the greenhouse and converts it into a long wave infrared radiation. What this does is basically allows the heat to come in the greenhouse, but it doesn't allow it to escape. Basically the same effect that you see when you park your car in the middle of summer under sun. You walk in, it's boiling hot. So solar greenhouses capture the infrared radiation and utilizes that heat to supply the energy needed to evaporate that water. Obviously, this is not entirely electricity free. For the system to work efficiently, round the clock, 24 hours and 365 days, especially in India, when 3 months is monsoon, on the best in the best scenario, and half of the time is highly humid, we have put in an automated system of ventilation as well as turning system. What this does is it allows the sludge to be constantly mixed in a very energy efficient way, in a very systemic, automated way, and the ventilation system to intelligently manage the flow of air to effectively dry the sludge at the lowest energy input and the lowest cost in the most reliable way on an year-to-year basis. The reliability is very important because when industry invests in something, they need it to work round the clock. Why? Because sludge is generated round the clock. If sludge is generated round the clock, you need it to dry round the clock. So this system allows that to happen. Now those are the benefits of how solar drying can help achieve what conventional thermal options does not allow us to achieve in a cost-effective manner. But then there are some other benefits of the system. You know, if you talk about the consumer of this technology, which is the sludge generation sites, they have an entirely different set of problems in their head other than the cost, which is sludge is not a pretty material, as I said earlier. It can smell. It can create issues for the people and the labor handling the material, as well as even the disposal sites. So solar greenhouses, especially the one that we have designed, has an automated system which is controlled by PLC using thermal sensors, which manages the operating temperature of this system below 70 degrees centigrade. Now this is a very critical cutoff, because below this, the way bacteria acts in the sludge, it does not generate the amount of gases which create the smell that we talk about. The continuous aeration prevents any sort of anaerobic activity and ensures that sludge can be dried into granules, very easy to handle, without necessarily creating the side effects that someone would imagine that, hey, this stinks, and if I'm going to blow air on it, it's probably going to stink more. But that doesn't happen. The third good thing about this technology is that it operates independent of the season. You know, in India, on an average, we receive 3 months of rainfall. What happens when there is a rainfall? If you take an hygrometer and try to measure the humidity, it will come upwards of 90%. When the humidity in the air is 90%, you are drying nothing. It's just not going to happen because the fundamental science prevents evaporation of water when there's already enough water in the air. This system, however, intelligently designs the capex or the size of this plant in such a way that your annual output can still be processed in a cost-effective way in the least amount of capex that you need to invest. Now, someone would ask, why would industry still adapt this? What are the costs involved? You know, earlier I mentioned this figure that if you dry it with conventional energy is 3 to 5 rupees per kg, and just transporting the sludge is 3 rupees per kg. So imagine you have a kg of sludge. You are not drying it, you're incurring 3 rupees of cost. If you're drying it, you're incurring 5 rupees of cost. In this system instead, you can dry the sludge at just 1 rupees of cost of drying per kg. What that does is reduces the volume of your sludge by 80%. So instead of filling a Narendra Modi stadium every year, we would fill it every 5 years. It's not the end of the solution, but it's still a great leap forward. So just based on the existing cost model, this is a solution which should appeal to all the solar sludge generation sites that, as it is, if they just employ this technology, their costs will go down in the long term. However, there's something we can do even better. One of the big things that we talk about in our country these days is circular economy and how we can repurpose waste to serve our goals of creating a circular economy. This, I think, would be a big clutch in that goal. The waste, the sludge that is generated out of the generation sites, when it's moist, it's useless. It's only a detriment to the environment, it's got no use. But once you dry it, and you dry it sufficiently, let's say beyond 80% dry solid content, then it can be very useful for replacing some of the coal that we used in coal-fired power plants. In our coal-fired power plants, we use massive amounts of coal. I'm sure we have all heard that come every summer when we start hitting peak loads, we start seeing articles in the news that we are not getting coal, the coal prices are shot up. So there is a big problem in acquiring enough coal as it is. So the end consumer, for example, the NTPCs of the world, they would be very happy to take this and utilize in their, for co-incineration in their coal-fired power plants. Based on the existing technology, you can replace almost 15 to 20% of your coal requirement based on, by replacing it with the dried sludge. That's a big figure. If you look at the numbers, I mean, just to give you an example, if 1/5 of India stopped using coal, what kind of benefits could it have for our economy, for our environment? That's the effect we are talking about. If 20% of our coal can be replaced with, very good question. So calorific value depends based on the moisture content and the type of the sludge. If you're looking at biological sludge that comes out of STPs, or chemical sludge that comes out of ETPs, very different calorific values. But at 10% moisture content, if we measure the calorific value of sewage sludge, which is the lower calorific value sludge, we hit right around 3,000 calories per kg. You know, that figure is a very interesting one. Why? Because lignite coal has a calorific value just below that. So in terms of energy intensity that the sludge can provide, it fits our purpose as it is. In fact, just yesterday, if someone was reading the newspapers, we heard the news, well, or last week, that India and China are slowly trying to transition from importing low quality coal to high quality, higher energy density coal. So one might ask that, hey, then if this is lignite coal, are we just going to create something that no one is going to use anyway? No, that's not the case. When we start transitioning from lower quality to higher quality, that's a 2-decade long transition. Even then, it's never 100% of the usage of high energy density coal. Lignite will always be used, especially in India, at least till the time we stop using it altogether. So there is great value proposition. If you talk about the consumers, if you talk to the consumers of this technology, not the final product, but this technology, you tell them that the ROI just based on the cost of this plant is 5 years, 5 to 6 years. But if you add a revenue model, we can reduce the ROI on this even up to 2 years. It depends on some factors. For example, is there a consumer downstream which can offtake all the material that you're producing and recycle all that waste? But the point is to say, This is a very real opportunity. Technologically, it's sound. It's a system that has been tested in countries outside. The economics of the system work. They work in costs as of today. 2 years from now, those costs are going to increase on the conventional side. So this is only going to go better. So this is a technology that offers a real solution to a very real problem. When I talk about the quantities of the sludge, we have to imagine how many cities we have, how much sludge we are generating. As our per capita consumption is increasing, that quantity is growing up. As our water treatment facilities, under the Namami Gange initiative, they have already taken a flight. They are going to grow even more. This sludge will quadruple in less than 10 years. Quadruple. So this is a solution that we really need to focus on and take it positively and see if it can help solve at least some part of the problem, if not all. So just to summarize some of the points and add a few new ones. To the user, there are benefits such as it helps achieve dryness up to 90% without any conventional energy input. It's a gold standard for utilizing that dried sludge into a revenue model. It helps minimize electrical input from the grid. What's better, for the little electricity that it uses, you can marry it with a local solar PV module, not a module, but a local solar PV setup, and use that to supply all the electricity needed for the plant. This helps us bring the circle back to how this technology can help further the goal of microgrids as well. That creating island architectures which can sustain on their own without creating undue pressure or loading on our central electrical grid. We don't talk about it enough in India because Indian government has been ahead of the curve, but up in the US, failing of electrical grids is not an uncommon topic. It fails all the time, especially because the way renewable energy is generated and transmitted onto the grid, the extreme loading and the unloading and the peaks that it creates, fails those electrical grids very, very easily and very frequently. But as we grow in our scale, this problem is only going to grow and increase. So adapting technologies that help solve the thermal requirements of the industry, at least in some form or manner, as well as help prepare us for those massive explosion in consumption of electrical energy by creating the microgrid structures. So with everything that is there, all the positive things that we talked about this technology, about its economics, why is it still not being adopted at large scale? Well, the answer is always money. Even though the operating costs are unbeatable by any other technology, there is a one-time capital expenditure involved, which is what requires that 5-year payback period time. So we ask that the societies and the government of the society needs to promote this in a way that helps reduce those hurdles. In a couple of ways we can achieve this. One is government or the regulators can come out with regulation and policy that helps either helps industry with the upfront investment, some part of it, to help reduce that initial shock that comes to the exchequer in investing in this technology. Second, they can help set up pilot plants. In Hindi we have this saying, "Jo dikhta hai, wo bikta hai." One of the great things about new technology is that it can solve problems that we really need solving and we don't have a good solution for. But one of the negative sides to this is there is certain uncertainty associated with it. If I tell you that this is a plant which requires $1 million investment and you can't see it working, you are going to think twice about investing or not, even if you find everything else working for you. So government and organizations from the industry can come forward and help establish pilot plants that demonstrate to the industry and our communities that this is a very viable technology, it works great, and it helps solve the problem of tomorrow. Third way, obviously, government always have a way to add costs to the unsustainable systems or the processes that we are following today. Don't forget, we are dumping this sludge in landfills today, thousands of tons of it, every day across India. Water is leaching through that sludge. It is polluting our land. It is polluting our water as we speak right now. That process doesn't stop. And today, tomorrow, and the day after, more trucks will go and dump more sludge in the same sites that continue to poison our environment. So let's not forget that part, how critical and why it is important that we adopt this. So government can still always come in and add regulation that requires sustainable disposal of waste that creates a risk for our ecology. And that, as in the industry we all know, that will entirely change the cost analysis of at what point it becomes beneficial. And finally, we also call government to promote the idea that adoption of this technology furthers our goal of creating microgrids and creating sustainable architectures that support our grids for the future. With that, I'll take a pause. We didn't have a second speaker yet, so I took my liberty with the time. I hope that's okay.